So we're on video 3 right now, and we're going to talk about something called enthalpy. And it's kind of a wordish thing, so I'm going to jump straight into what the book defines enthalpy as, and then I'll kind of give you a more gentle version of this. So it's going to be kind of a short video, so stick with me here. So the book, actually, when it's defining enthalpy, says that H, enthalpy, is equal to the internal energy plus pressure times volume. They chose H for enthalpy, kind of fun, because there's so many like enthalpy energy that E was already taken with energy. So they made H for enthalpy because that makes sense, right? This formula allows us to define what enthalpy is, but it's not super helpful for us. There's a derivation of this in the textbook, and this only occurs at constant pressure. And this is going to be useful for us. And it's this, that the change in enthalpy, because energy changes are what we record. Things don't typically have a certain amount of heat or energy. They typically give a certain amount of heat or energy when they do something. We say that change in enthalpy is equal to heat at constant pressure. Remember this Q that we just saw before in when we were talking about Q and W. Now, what are these actually defined as? Well, change in H is the change of enthalpy in a system. QP is the flow of heat energy at constant pressure. Now, this is a little bit confusing, but essentially what this says is that whenever we have constant pressure, the change in enthalpy is equal to the energy flow. And what that allows us is to use Q and change in H kind of interchangeably. It also allows us to give us a little bit better of a definition for enthalpy because, well, there's two definitions. The wordy one I'm going to give you right now, it says enthalpy of a substance is enthalpy is the amount of energy that comes from its bonds. And notice how we just use the simple H, but we rarely use H. We almost always use change in enthalpy because we're concerned about energy being transferred from one thing to another. So enthalpy change, which is a lot better, is the flow of energy in a system. So we're going to use that as our definition for enthalpy, or change in enthalpy. Now, there are a few ground rules that we know from before, and it's pretty straightforward. We know this: all substances want to be in a low state of energy. That's their goal. In fact, you walk up to any atom ever, and if you take a look at me right now, if you walk up to any atom and say, what would make you happy? They always say want to be at lower energy. Now, if I were to take two atoms that are by themselves, they are going to have high energy. Remember, the height of my screen right now is energy. When they bond, by default, they always lose energy. They release energy. Now, if we have a bond and we want to break it, we've got to put energy into that bond to break it back apart. If we start off with atoms right here at low energy, and when they formed a bond, they ended up at higher energy, that bond would never ever form, because why would they ever bother doing that, right? So reactions are almost always more likely to occur when we have less energy in the products than we do on the reactant side. That's just truth, which is why exothermic reactions are much more likely to occur than endothermic ones, which begs the question, well, why in the heck would an endothermic reaction ever work, ever? And we'll get to that. Now, to close up the video, we're going to talk about 4 different ways. Enthalpy is an amazingly huge portion of thermodynamics. And we're going to figure out 4 ways to calculate it. And the first one here, we're going to talk about in the next video, is calorimetry. You're going to see this table with you throughout the rest of this unit. But note that we're going to be going one after another. And at the end, you're going to have 4 different ways that we can calculate change in H. Hopefully this has been helpful. We'll see you in the next video.